we still have space for 3 more students. Okay, so if anyone here who's not registered but would like to take this course can come to me after class and sign up. Okay? So this is the title of the course, and it's a lab, and it's a design lab, and we're designing the robot based on AI. Okay? And there are 4 professors involved in this design course. Myself, Yu Chang, there is Professor An Hee-jin, there's a Professor Kim Min-jun, and there's Professor Myung-hyun. Okay, there are 4 professors involved in this design course, and there are 11 TAs. Okay. So, what is the objective of this course? I just want to make it clear. It says it very clearly here. This course combines theory and practice to equip students with the skills to design robotic intelligence. We're not here to design a robot. We are here to design a software, which is the intelligence that goes into this robot, that integrates computer vision software, large language model. You could actually download an LLM here, okay? And we're going to teach you how to do reinforcement learning, which is an AI topic that allows policies to be generated. Policy is, given the situation, what sort of action the robot is supposed to do. Okay? And so students will develop robots capable of autonomously performing diverse tasks, and I'm going to be talking about this just a little bit more, in an unstructured, so it's not a fixed structure, but it's just some random structure that will be given to the robot in a non-standardized environment, and through effective perception, planning, and control, it's supposed to complete the task. Okay? So that is the objective of this course, and there is no other course in this world that will teach you to do this. This is the first course in this world that will combine computer vision, LLM, reinforcement learning, robotic kinematics, all of that, to do this. Okay? And I'm planning, I'll talk about, so the key topic is there will be an operating system, a platform, and we're going to be using ROS. Okay, ROS 1 and ROS 2, but probably we'll focus on ROS 2. The robot needs to see the environment. So we're going to use SLAM, we're going to use various computer vision techniques to understand the environment. Then we're going to give it various tasks, and it needs to plan the steps in performing these various tasks. And it needs to have some control in executing the plan. And it's going to be using reinforcement learning, various knowledge about robots to complete this task. Okay. So these are the key topics that will be covered here. But this is a lab course. So we cannot go and discuss all of this in detail. It will sort of be mentioned, and you would have to go and talk and do research. You talk with ChatGPT to find out more information about these things. Okay. So you need to be very proactive in this course. If you're expecting us to teach you A to Z, no. There's too much material. Okay? And this is a senior lab course. So we're expecting that you know a certain amount of various things. Okay? And we will be providing various references. So, robot, where are we with robots? Humanoid robots are available right now. You could buy these things, and they could dance, they could perform various things. And most of these things are based on, human manipulation. Okay, there's someone controlling these robots in the back. Okay. And they're doing this motion in by some program, a fixed program in a fixed environment. But we want to do this in an unstructured environment. Okay? And of course, the robots are not. It seems the robot is perfect, but robots are not. They fall down and they do a lot of dumb things. But this pretty much gives you the idea of where robots are. Okay. In terms of AI, it can sense the world fairly well. We have object detectors to detect humanoid, pedestrians, lights, buildings, various objects very, very well, better than humans. Okay, and it could, segment the the image that it sees. So in terms of perception, sensing the world, it does a very, very good job. They can do a very good job. There are computer vision algorithms that can do better than you. Planning. You plan. When you come to class like this, you plan what time, what building. You go to the third floor, you take the elevator. There's a lot of planning. Planning, we can do it very well. AlphaGo does a lot of planning. Planning many, many steps ahead to win the Go match. Some cities already have autonomous driving. There are taxis that come and pick you up, and you can go somewhere. Planning is at a human level right now. We can do this motion now. This is not based on some fixed C program, deterministic. This is based on learning, reinforcement learning. So this is where we are right now. This is where we are. And obviously, there are artificial intelligence everywhere, and you're using artificial intelligence every day to do your homework, to do various things. And I expect that you use ChatGPT to the fullest, okay? But don't turn in, if you turn in homework or reports that is done by an LLM, you will be penalized. Your work has to be your own. Okay? But what this shows is there are various LLMs that are presented. Just recently, OpenAI, ChatGPT 5 was released a couple of months ago. DeepSeek, Llama, there is Meta, Llama, Anthropic Claude, Gronk. They're freely available, and they can advise you various things. And the performance of this is going up, it's rising, it's improving each year. Its performance is rising at an exponential rate. So it's only a matter of time. It's obvious that you put one of these things into a machine and it will be able to communicate with you and run around with you. So, this course is to prepare you, or this course is to have you exposed to this new field of integrating artificial intelligence into robotics. And you will be the star of our effort. And we'll have a session, project session, and we'll invite leaders from various areas to watch and be amazed by your output. So this is figure 2. I don't know if you've seen this video. Helix. So it's a company called Figure. Let me know the volume of this.
소리 안 나와? 아니 그래. 거기다. 소리 자체가.
But anyways, this is probably the future. Human interacting with a machine to do various tasks. And here in this video, human brings in groceries, and the robot is to take the groceries and place them in the appropriate place in the refrigerator. So ice cream goes into the freezer, eggs go into the egg basket, and so forth. Okay, very nice. Okay, so this new field is called physical AI or embedded AI. You're embedding AI into a machine. Okay, so physical AI refers to integration of artificial intelligence into physical systems such as robots, car, robot, drones, in your home, various places, in your phone already. Okay? And it's interacting with the world. And physical AI is where we are heading. That's probably the ultimate destination of where AI is advancing. This is Yansun Wang. I hope maybe some of you are familiar with him. He has a company called NVIDIA that makes GPU, and GPUs are used for training the large language models or artificial intelligence. And this is his view. Okay. Perception, computer vision, perception of the world, sensing the world, generative AI, producing text, producing images, producing policies for robots, agentic AI to do more complicated tasks autonomously. Then there is physical AI. Physical AI, embedded AI, which is integration of perception, planning, and control. So real world, there's going to be sensors, there is going to be machines to take you places, wheels, joints, motors, so forth. And so you perceive the world, you're going to use SLAM, computer vision, VLM to understand the world. You do some planning, then you're controlling the motors to move around in this real world. Okay. And these are the topics that will be covered in this course. Many of these. So as I said, there are 4 professors, each with their own specialty. The ultimate goal of this course is to design intelligent robots. Students will be provided with this. Okay, this is fairly expensive. I think it's close to $2,000. And 250만 원. Okay, and it has motor. It has an RGB camera. It has LiDAR. It has memory. It has CPU. And it's 5 degrees of freedom. It's got an arm to pick up things. And there will be also software for this. Okay. ROS, SLAM, some of these basic computer vision algorithms, ROS, PLAT, and so forth. And it will be your job to integrate these various components to do a certain task. Okay. And you will be asked to solve a real problem, which I will show you as well. So today is the first lecture. There's no labs. I should say this. And the second week, we'll have a lecture on ROS, okay, which is platform operating system for a robot. And there's no labs for this second week. Then the third week, Professor Myung will talk about SLAM. Okay, simultaneous localization. It goes around using LiDAR to map out the world. Okay. And then you're going to learn about robot control, manipulation, and then we have, and after each lecture, there will be sort of a small lab. Okay. Robot manipulation, teleoperation, planning, and then various AI, computer vision, LLMs, and reinforcement learning. And then you will have 4 weeks to do a project. So, what is the project? You will be given a random environment. And your first task is to map out the environment, okay, and then do various tasks in this new environment that's given to you. And this environment will not be given to you beforehand. So you would design your intelligence such that on that day you'll be shown a new environment, and you would need to map out and perform various tasks. So random environment will be provided on a certain day, and your task will be given in some text form. So for instance, pick up the blue block, put it in the blue basket, take the red and put it on top of the yellow block, and then finally reach point B. Okay? And it will, so you design the intelligence here such that, okay, go map it out, and then we give you this task. Let's use a task, and you just give it to it, and it would need to perform that task autonomously without you interrupting. Okay? So this is a very challenging course. We will not give you an environment, couple of weeks, ahead of time, and you program all of this. No. I should just say that there are prerequisites for this course. We are expecting that you know how to program. You know a little bit of probability to understand various computer vision and planning, techniques that we will show you. We are sort of expecting that you had a little bit of AI. One course is Introduction to Machine Learning 331, which I'm teaching at the moment right now. Had a little bit of control. Okay. So this is what we're expecting. You don't need to know this thing really, just hope that you had some experience with this. And what's probably the most important to you is the grading system. There will be weekly labs. Okay. We expect that there will be maybe 12 or 10, yeah. That's 40%. And the project will be 60%. So for the project, you know, as I said, you're given environment, and your robot is to perform the task, and we would judge you on various criteria. We'll give you how we are going to grade you. So it's the time that would, so we would look at the program, how big is your program, how accurate is your program, how much time it took, the effort that you made, all these things. So your environment will look like this. And it will be some random environment. So the course, you're here 4 to 5:30. We'll try to let you go at 5:15. Okay, so you can go and have dinner. We'll meet here. And about labs. So you select the team. So as I said, there will be 12 robots available per team. And there are 3 members in the team. Okay? And each team will select one of these labs. Okay, Class A, B, C. A means Monday from 2:30 to 5:30. 2:30 to 5:30, and so forth. You choose one, and it's here. And my lecture, or everyone's lecture, will be uploaded in YouTube, on YouTube. If you miss it, you can always look at the YouTube. This is detail. I think this is what we're going to try to do today. So there will be 12 teams, and each team will consist of 3 members. Okay, also 14 teams, and there will be 1 robot per team. You will be assigned a particular robot. You would check for its, I don't know, if there's any defect, okay? And we expect that you return this robot in the same condition. If anything is not working, then you will be penalized. So you must take good care of these robots because they're fairly expensive. So once the teams are set first week, that team will go on throughout the course. And they will be doing all the labs together and the projects. Okay. So I think you sign up for the teams here. Is that right? And I think some of you already started doing it. Grades. Grades will not be given to the team. Grades will be given to individuals. Okay, so each of you will produce an individual report. Okay, and you will be graded on that. And we will ask you to tell us exactly what your role is. Okay? If your role is fuzzy, then you may not get a lot of points. Your role has to be very, very clear. Yeah, and all code and report must be of your own work, but we encourage you to use LLM, ChatGPT, artificial as much as possible. Okay? And you shouldn't, obviously, you shouldn't copy someone else's work. And we will also, the code that you turn in, we are going to check whether that code was not generated by ChatGPT. Okay? If you're found that ChatGPT made your code or considerable amount of it, then you will be penalized. Okay? But you know, you can ask ChatGPT to give you an example of the code. You look at it, you understand it, and if you implement it on your own, in a maybe sort of a different way, that's fine. Some labs may not require lab reports. And the only thing that you have to do is to demonstrate that you've completed them. So this is the robot, okay? And I sort of mentioned it. It's about 5-6 kilos, okay? And it already has ROS. It has SLAM. So you just type in, you know, this function, and it will map out the environment. Okay. It has RGB camera, you know, and it has 8 gigabytes of memory for you to upload various LLMs. Not big LLMs, but you know, a small size LLM. You don't need ChatGPT on here. You're doing some simple tasks, so you don't need a very, what do you call it, a high-performing element for this. 6 degrees of freedom for this robot arm, LiDAR. It's a single-channel LiDAR, by the way. Single channel. Let's see, there's video. And there's a website for this, I think it's Hi World, and you will see a whole lot of software for this. This is what our TAs did. So gave an instruction to this robot. Okay, after, this is based on reinforcement learning. Based on reinforcement learning. You have 3, I don't know, baskets, a gray one and a white one. You have a colored block, and it's been trained to pick up the block and put it in basket. It's been, and then you give this this task: put the green cube on the gray plate. Okay. That's given in text. The text will be transmitted from your notebook to this. communication link between this. So you give it a tag, your instruction, you would put it here, and then the LLM will process all of that. And so it recognizes where the green block is, it knows how to pick it up. It recognizes white from gray. And this is simple. You're going to be doing something a little bit more complicated with this. Okay, each week there will be TAs to help you do the lab and to understand the material. Professor Kim Min-jun will be giving his lecture via Zoom because he's not physically here. And of course, if you have any questions with regards to the lab and so forth, then we have provided email address. And we have head TA. I don't know why it's a general TA. He's sitting in the back, Young-han. So you can get in touch with him. Okay. So that's the logistics for this course. If you have questions, please post them to me right now. You can ask me in Korean or any other language.
Yes, sir.
Yeah.
Question. It's kind of specific question, but as I know that Jetson Nano, we have to install the package one by one because it is very small environment related to our GPU in server. So then we have to also install that one by one line on the Jetson Nano, or it is already implemented.
It's already implemented. Many of it, it's already in there. But anything that you want to do extra, you can do it. You can upload it. Okay, so the LLMs and various. I don't know if the LLM is available right now, but you would have to upload it.
The Jetson Nano, as I know that 8 gigabytes.
We have 8 gig. Yeah, 8 gig.
It is the shared RAM for the memory and the GPU inference, or only for the inference, the 8 gigabyte?
I don't know. I have to find out about that.
Could we fix the codes already testing the?
You can do whatever you want.
SLAM also is.
SLAM is in there. There's a particular kind of SLAM. 그 SLAM 이름이 무슨 SLAM이라고 했죠? 어? Capital SLAM. That's a particular SLAM that's already in here. 네.
저분도 LLM 관련 질문을 주신 것 같은데 제가 잘 못해가지고 저희가 로봇 안에 오픈소스 LLM을 모델을 가져와서 안에서 임플리먼트를 하게 되는 형식을
그렇게 하셔도 네, 그렇게.
그러면 챗GPT나 제미니 같은 이미 나와 있는 LLM들의 API를 가지고 와서 인터넷식으로 연결을 하는 방법도 가능한 건가요?
인터넷으로 계속 연결하는 거는 할 수만 있다면 하세요. 근데 인터넷이랑 통신이 그렇게 자유롭지는 않을 것 같은 생각으로. 그리고 챗GPT 앱을 쓰려면 돈도 들고 그렇기 때문에 yeah, you want to use what is it? Open software, small LLM. There are many small LLMs. Why would you want to put ChatGPT here? So I mean, we'll touch upon various, topics, okay, and you would have to study on your own and use your creativity. Use your creativity to the fullest. Teamwork to do the final project, okay? And the objective is you're given something and you ask this robot to do that thing by text, and he will do it. It should do it. But we're not going to ask this robot to go outside and buy some ice cream and then bring it to the TAs. It's not going to be something like this, right? It's going to be like picking up the blogs, some environments that you have been working, that you're familiar with, that's been studied in the lab, that's been introduced in the lab. You have questions?
I was going to ask if do we only have the last 4 weeks to work on the final project, or do we have a more amount of time, but those last 4 weeks are only reserved for the final project?
Well, your team will be assigned to a particular robot, okay? And we will be asking you to do a certain task for each week. But you're welcome to do whatever you want if you have time. We would like, if you need more time, or if you want to work outside those labs, then you probably have to ask the TAs and so we'll have to think about that, whether if it's possible for you to take this, or that you have to use this robot in this particular environment. We haven't decided, but probably this robot needs to stay in that environment throughout. But you can come whatever you want when the tea is over. So the time that I showed you in the slide is the time that we will be responsible for. So this is going to be a very, very exciting lab. There is no lab like this in this whole world. You'll be the first. And this is physical AI. This is physical AI. Okay, so who's here? Who's not registered here in this case, but would like? Everyone's registered here. Who's just no one's shopping? Huh? And also, it's 3 members to a team, right? Now, if you decide to drop this course, you are putting the other two in a very disadvantaged position. So the members need to commit to this project. Well, anyone who doesn't have a team or who's not part of a team, please raise your hand. Okay, so we can see all of you here after class and randomly make a team. Okay, if that's okay. And of course, you would probably need to talk amongst yourselves because you want to form a strong team. Or the team members need to sort of complement one another. Okay, so that's it from me. Any comments or more questions? 질문 있어요? This I have big hopes for this lab. This is the first time we're doing it, and I'm going to invite various company leaders to come and watch a demonstration. Okay, and it may be a good opportunity for you to get a job or some, you're determine your next destination. Okay, so that's it. 혹시 뭐 질문 있나요 여기? So next week we will have a Ross by Professor Myung-Hyun. 그게 다음 주 금요일인가요? 네. There will be no class. So it's usually a lecture, and then the following week you would have a lab associated with that lecture. And that's how it's going to be. 네, 그러면은 so that's it. If you're set, if you have a team and everything's set, you can leave. If you don't have a team